Okay, good morning. We are the Sky Fire team. Our project is the unmanned aerial vehicle with fire extinguisher grenade release and inspection system. Group members are Miriam Freitas, Alex Morillo, and Cesar Beltran. The problem statement: lack of UAV with the purpose of extinguishing fires or to help to prevent one. The current extinguished fire systems that are in place in buildings and houses cause plenty of damage because we know they use water, and water in contact with the electronics, they are going to get damaged. There is a deficiency or shortage of fire prevention methods in forests. The motivation of the group is to decrease the risk taken by first responder personnel by limiting their exposure, reduce the cost of fire extinguish methods, implement the UAV system technology in the firefighting field, cause less damage, less structural damage when suppressing a fire inside of a building. The objective of our project is to create a system to release the fire extinguish grenade release inside of using a UAV, incorporate a camera for fire inspection and guidance, include the stability control sensors to have a better manipulation of the UAV at the time we are deploying the grenade.
Okay, the main factors taken into account when we decided to do this UAV were first our payload, which is the fire extinguishing grenade. The second was stability, the cost of the entire system, the ease of assembly, and also the lift power produced by the motors. For this structure, we decided to create and design a quadcopter, which is a frame with 4 arms that have 4 motors. The main components are the frame, the 4 motors, the propellers, and the camera. In order to make this selection, we decided that they had to be lightweight, strong, the motors had to provide enough lift power, and the camera had to be high definition. The weight of all these components with the release mechanism or the battery is around 1.15 kilograms. In here, it's important to mention that each motor provides 2.8 kilograms of lift. We have 4 motors, so we have 11.2 kilograms of lift. But in order to have an efficient quadcopter, its maximum weight cannot exceed half of that, which is 5.6 kilograms. The specifications of the fire extinguishing bulb that it weighs around 1.5 kilograms. It activates within 3 seconds of contacting the fire, and its operational effective volume is 9.12 meters cubes. This is how it works. Okay, so now we're going to design and manufacture the release mechanism. We decided to put it below the frame because this is the easiest way to drop the fire extinguishing bulb. For this design, we decided to use a platform and rails, which will mainly be made of carbon fiber. The bulb is going to be released with a pin that will be controlled by the controller in ground, and when the quadcopter is placed in the location in which the bulb is going to be released, the ramp is going to move at a certain angle using a servo motor that is going to be controlled by the person in ground. The major constraints of this project is that the quadcopter cannot be on top of the frame. It means that it cannot also be in direct contact with the fire, or otherwise the systems will fail. And also is that the quadcopter cannot enter in a structure that is sealed, meaning that if there is a fire in a building and the windows are closed, the quadcopter cannot deliver the fire extinguishing bulb.
Okay, this is our cost analysis. Everything with including the fire extinguishing grenade and the materials for the release mechanism is going to be around $2,000. We have a cost estimate for the release mechanism of $200, and that includes everything for the controllers, the GPS, and the camera. This is our timeline. We started doing the research and design in February. Right now we are doing the computer simulations, and we are already purchasing the parts for having the UAV already assembled by summer, so we can do the testing of the release mechanism by the end of the summer. This is our breakdown of responsibilities. Every single team member is going to have their part in the construction of the UAV, but there's going to be a leader for each specific task. Cesar is going to have the design and optimization and testing analysis. Miriam Ferry is going to be the leader for manufacturing the release mechanism and the reports, and I'm going to be the leader for the cost analysis, assembly, and programming of the quadcopter and release mechanism. For a global perspective, we take into account that there are fires everywhere in the world. This can be used in every single country that it's needed. We're going to have our manuals in SI and English units and 3 major languages. Questions?
Can you control each of the 4 motors independently?
It depends on the stability of the quadcopter. So it works according to because it works with a gyroscope that is included in the RD flyer. The RD flyer is the main controller. So each motor has a controller that goes connected to the RD flyer. So it depending on what way it's moving towards, it will stabilize itself.
Okay. And really where my question played to is there a reason why you designed the carrier, the drive system, asymmetric on a symmetrical design like this? It's got one arm laying down a long way off of one side. That obviously means I have to have a different kind of lift on that side of this robot versus the other side, or this thing's gonna be unstable at all times.
Yes.
Whereas I could design that to be symmetrical,
Right.
and now all of a sudden I've got a counterweight. So I've got it
Yes.
designed so itself
We
counterweight.
want to do the testing in summer. We want to have this part when it's taking off, like right in the middle. So when we're approaching the target, we're going to have it released. So it doesn't take too much time to stabilize itself, because we want to do this as fast as possible. So this is a rough design of the release mechanism. But mainly we have to have weight distribution along the frame of the quadcopter. That's a big thing.
Is there a reason why it has to be so long?
Mainly because we don't want the quadcopter as close to the fire, because the components will melt. We have some plastic in the tubes.
How
So we
long does
have
it
a-
have to be to get you far enough from the fire that the helicopter doesn't?
We're doing the testing in SolidWorks for the temperature. We have a certain amount of time that this has to roll down.
No, I was thinking of alternatives. This is a good engineering project, but I was thinking of an artillery piece, like an artillery gun where you can control the velocity and you can calculate where you want it to hit and do a calculation. You could probably throw that through a window with a projectile. But, that's just a thing I'm thinking outside loud, but I like that.
The thing is that mainly, right now, all UAVs are being built with military purposes. We wanted to innovate with this.
Okay. Well, I didn't mean military, but it's a real bomb. Shooting one of those things in there would be pretty cool.
Besides, follow up with the questions here. I know you said you're using a lot of plastics and carbon fiber here, because that's going to use resin. It's very flammable. So, have you thought about other materials that are less resistant to heat and melting? Have you thought about that?
We don't have another material in mind right now, but we need to run the SolidWorks simulations. Because the thing is that this is a really strong material and it's also lightweight. So that's why we made the rails extra long, so the quadcopter shouldn't be that close to the fire.
Our main concern at the beginning was the weight of the quadcopter. The other concern was the thrust of each motor. We don't want to don't have enough lifting weight for the mechanism and the ball.
How much the ball weight?
1.5 kilograms.
Okay, if you're not getting so close to the fire, obviously you're going to have it be able to launch that ball into the fire. Now, what kind of distance are you talking about?
The rail is going to move. That's why it has a servo motor in here. So it's going to move. Therefore, when the quadcopter is, for example, in a window, it's going to move a little bit, so the ball is just going to roll.
Are you gonna take into account downdraft?
Excuse me?
A concern I have with a fire is that it's combusting oxygen. So classically, you have a different kind of airflow around a fire than you do in normal space. How you can compensate for that?
The reason why we want to have this ready by summer, so we can do the testing, we're gonna test this in not in flames, but we're gonna put some smoke around it to see how because the servo, the idle flyer is supposed to be controlling the stability of the quadcopter. So, but we haven't found any tests on smoke.
But you gotta change the density of the air to real get a real, not just smoke.
Simulate changes.
Because
Yeah.
to simulate the fire, you need to have a less dense mass when it's heated up. You're gonna have less lift.
That's another goal of the release mechanism of the rails, because it's gonna we want to have this at the border of the window, so it holds it there.
You can break the glass and everything with that.
No, that's one of
That's what's the main
Most of the
constraint.
buildings have high impact windows,
Yeah.
but most of the fires, when a fire starts, the first thing that explodes is a window.
You said you're gonna have manuals in English, Spanish, and German, right? Why German?
Yes.
That's a living country in engineering.
And
And this is an innovative idea. We wanted to take advantage of it.
Good answer.
Okay.
yeah, we
Just one quick one. Can you discuss a little bit the different concerns associated with how quickly first responders can get to a fire, and hopefully maybe your specific quadcopter could get to a fire much quicker than those people? And exactly maybe add how much your quadcopter could save in terms of damage and cost?
We saw different videos, and for example, on YouTube, it takes like sometimes 10 minutes to get a ladder or a fire truck to a different part of the building. If we have one of these quadcopters just in place, it's gonna take like I think 2 minutes just to deploy one grenade, and then just get the quadcopter pretty low and deploy again the next grenade.
So you're gonna have this as a permanent fixture as part of the building, so in case a fire starts, it automatically.
It
Does
will
this
be,
work
it
for
will
the
be some
response?
type of requirement for buildings to have this. That will be something new to employ. Where is thinking of it?
Okay,
So-
good.
Something that we have to mention is it's not autonomous. It's gonna
Right.
be central.
Has to be controlled, okay. But assuming it'll be a firefighter who's controlling it.
Exactly.
Okay, so you still have to wait for them to arrive anyway.
Well, they can control it from the fire station they have.
No,
That's-
they can have it in the fire truck. It's gonna be easy for them just to start deploying the grenades until a big fire truck gets to the scene. It's gonna be quick for them to respond to any fire.
Because it takes time to extend the ladder,
Right.
have someone go up the ladder with the
Right.
hose and start spraying water.
No, I understand that part, it's just, I'm thinking, how is it gonna be quicker if you still have to wait for them to arrive? You know?
The thing is that taking the hose from the fire truck and also installing it to the hydrant, it takes time. With this, it will be just taking out the quadcopter, loading the ball, and
But the thing is that the ball has a limited size room that it can handle. Instead of 95 meters.
ideally, the fire truck will have 3 or 4 quadcopters.
So, no, I'm just thinking delivery system on how fast that could be, but no, I mean, I think it's a good engineering practice, you know, to do this, but
We need to do a lot of
there's some
testing.
issues that you gotta think about when, different alternatives and what you're competing with, because, it's a neat idea, but I might be able to throw a ball in there faster than getting a helicopter in there, you know what I'm saying?
What about if it is a 30th floor?
But,
The 30th floor of a building?
no, even the third floor maybe, you know, but what I'm saying is, somebody who run up there and throw it in the room, you know what I'm saying? You know, just keep in mind different alternatives to that, that doesn't really require, there's gonna be, in my opinion, is to use this delivery system is gonna be for a very specific use. It's not gonna be for any house on the third floor in the window. You could run up there and throw the ball faster than you get that unit ready and loaded up and programmed and set up there. So I'm just saying, keep that in mind. I think it's a good engineering training practice project, but there are alternatives to that, and you should discuss that option as well. But you might be able to find a specific niche for this that would be perfect.
Multi-story buildings.
Exactly, a skyscraper.
Yeah.
Well, so if you had a thermal camera on there too, so for instance, say the fire alarm went off in a building, you had a thermal camera on your quadcopter. The fire alarm goes off, you raise it up in the air, if it's autonomous, it can see exactly where the fire is, drop something right in that window, and you extinguish a fire in 2 seconds that maybe would, you know, wipe out a whole community if the fire truck can't get
That's a
there.
good idea. Also, would the chemicals snuff out the people too? Is there people in there? Because I know
Right,
Halen's a problem.
yeah, right.
So if it sucks out the oxygen in the room, then that's how it extinguishes the fire.
It's an assumption that people is on the side.
Oh, actually. So you hope there's nobody in there.
Well, if it's a big fire that it requires these, people already have problems, hopefully.
It's a first step towards all of that.
Yeah. You know, I think it's, like I said, it's just a lot of things to think about, but it's pretty cool.
But the other use that we're thinking about it is for forest preventing, because there are hard to reach areas where the firefighters, they can only go around the fire, but they can start throwing these balls around it so when the fire gets set to the place, it
Just have to-
stops it.
Thank you very much.
All right.